Before we get started using the laser, the first thing we have to do is actually turn on this power strip the way it's currently set up. This power strip controls the monitor for the laser. It also controls the exhaust fan and the air compressor. You need both of these on before you send programs to the laser so you don't accidentally run it without those being on. We also need to turn on the overhead hood. And the laser itself. So we'll turn all these items on before we start sending programs over. Before I start these up and it gets noisy, I will point out this board over here has a few key notes. One of the most important is that you can't run the laser above 80% power. There is no external cooling unit or chiller on this laser, and above 80% you risk damaging the laser. Another key point is we're not going to use any plastics on this laser, and in general we don't use plastics on most of the projects. Plastics like PVC emit chlorine gas from the chlorine in there, and then items like ABS have cyanide in them. So other plastics will either char and burn, or they have noxious fumes associated with them. You can, in some cases, use plastics. You research on your own, do your own due diligence, and then bring the case forward why you want to use plastics and which specific plastic you want to use. That's okay in some cases, but don't assume you can cut any plastics in this lab. So now I'm going to get everything started. First, I'm going to turn on the power strip. It kicks on the air compressor, but sometimes students will turn the air compressor off independently. So if you don't hear that kick on, go ahead and turn it on. This one you can feel if it's on or not. It's kind of quiet. I'll then turn on the overhead hood, and I'll turn the laser itself on. The laser is going to go through a startup sequence. All these lights are going to blink. And it's going to rehome itself. And then once this is finished, you can begin sending files over. So now that I have everything turned on, I'm going to copy my image to the computer. You typically don't want to work off a thumb drive, so I've already copied my files over here. I'm then going to open up Engrave Lab, this large E. It does say photo laser. When you click on it, you'll see it is called Engrave Lab. I prefer to have the plate size match the output on the laser itself, but most students seem to prefer to have the plate size match their part, so I'm going to go ahead and do it that way. I'll just change these numbers so you can see it change on the screen. So now I have this. We can pretend this is the size of my part. I can now import the image that I want to work with. You can import most common image types, bitmap, PNG, or JPEG. Those all work just fine. If you're going to do that, you need to make sure that it's a very clear image. So you can see this here. This is nearly 14 inches across, and when you zoom in, it's not that grainy. If the image is grainy or the color is off, it's going to print it that exact same way. So I'm going to change this to 4x4, roundabouts, 4x whatever. I'm then going to bring in the other type. We can also do vector file. So this is a DXF. You can save a SolidWorks file as a DXF. And I'll make this 4 inches as well. I will have a complete video, a more detailed video, showing how you can convert a standard image over to a vector file, and I'll explain that video in more detail as to why you'd want to do that. I'll have that in that video. We'll also explain how you can set up a vector file to make it cut for you, and that video will go over how to make your cut time faster. So if you want to get your cut time as quick as possible, in that video I'll kind of talk over a few print strategies to help you on that. The big overview is typically most students want to raster. So a raster is when the printer goes back and forth and it just fills everything in and it makes everything dark. Most students want to raster, and most of the time they just download an image and send it over. In most cases it looks fine. You can, with a vector file, you can do a cut where it'll trace just the lines. It'll trace around everything. Or you can have it do a raster where it fills everything in. With the vector file, you have more control over what it's rastering and what color it is. And with the vector file, you can have some elements be raster and some elements be vector. So if you wanted the Ohio to be filled in and you wanted the face to just be traced out, you have that option with the DXF file or the vector file. So there's more control in the vector, but in most cases students choose to just import an image and then print that image directly, which is fine. So I'm going to go ahead and recenter this to the middle. So I have it anchored from the center point here, and I'll go over 4 inches, 5 inches it looks like. So now it's in the center of my part. I do encourage you to not eyeball it, to use these settings over here to control where it's going to be placed. Now that I have the image placed where I want it to go, I'm going to go to File, then Print, and then I'm going to go to Setup. The first thing I need to do is I need to make my plate size match my piece size. So I think that was 10 by 8. Now I have 3 settings I'm going to work with. I'm going to work with the DPI, the speed, and the power. As you increase the power up to the maximum of 80%, it'll cut a darker piece. As you decrease the speed, it'll cut darker, and if you increase the DPI, it'll make it darker. And then the inverse will make it faster. So if you want it to cut faster, you increase the speed, or you decrease the DPI to make it cut faster. You don't want to go above 300 when engraving in wood. A good starting point is around 200 with 80 speed and 50 power, and you can play with these to find out what works best with your specific material. Once you have the DPI, power, and speed set, you can just press OK. OK again, it'll give you a preview, and you just hit print. Now that I've finished programming my part, I'm going to load the piece of material into the laser, and I'm going to set the focus length. So I'm going to take my piece of material, place it in the upper left corner. There is a setup gauge. It will hang on these 2 little screws here, and then I'm going to toggle down to the focus tab. So you see the green light jumps down to focus, and then I can control the height. Once you get near the top, you can push the joystick to the side, and then it'll move slower. You can move the setup gauge off to the side and then lower it back down, and then once it starts swinging freely, you're about at the right height. Or you can just bring it up till it stops moving. So now you know it's about set. Once I have it set, just press down on the joystick and then go back up to the Job tab. Now all I have to do is shut the laser and press go. Now that my first part's finished, in this case I've sent a second job and I want to change the 0 just to test a few parts real quickly. To change jobs, all you have to do is push up or down on the joystick. So now I'm on job 2. And then to change where the laser is going to actually place the part, I can go to jog and I can move the laser over. If I want, I can turn the lights off and I can press this red icon here and it will give me a little indicator light, which you may not be able to see on camera. But I'm going to set that to the top, just to the side of this first part. Set that as my new origin. On job 2, I'm going to hit go, and now I'm going to have a second item for rapidly testing different cuts or different programs. Alright, I'll do a quick review on some parts. What you can do to test how deep you want it to laser is just make like a 1 inch or 3/4 inch circle, and then you can vary the speed, power, and DPI. This down here was at 1200 DPI and it basically just roasted the wood. But you can vary those parameters and find one that engraves it as deep as you want. In some cases you might burn through the outer layer. In this case it was right in the middle, so it looks kind of bad. You can have it set up to where it burns all the way through that first layer, or to where it just stays on top of that first layer. You can kind of play with those parameters yourself. Between these parts, all of these took about 1.5 minutes per logo. I used the same speed and feed as I did on these ones. So all of these were done at a vector speed of 100 and a vector power of 15. So all the cutting was done at 115. And then all of the rasterings on both of these, the raster was a speed of 60, power of 50, and a DPI of 300. So these took about 2 minutes, 1.5 minutes, sorry. These took about 1.5 minutes. Those are 2-inch ones. The 3-inch one took 1 minute and 38 seconds, so there's about an 8-second difference when you make it larger. Whereas the raster version here took 2.5 minutes, 2 minutes 35 seconds. It's the exact same speed, power, and DPI as these. Making it slightly larger took 1 minute longer. I was able to get it back down to 1:46 by having the power up to 80 and the DPI down to 200. It is a little lighter, and if you look at it closely, you can see a little bit of the pixelation. It may also sand off a little easier, so those are some considerations. But I got this to less than 2 minutes at a 3" by 3" roundabout part. And then here's just a grid of parts that I had done earlier when I was playing with the different fills, parts being filled in different ways.